Hello students, welcome to the chemistry sessions, and what I have brought for you today is the questionnaire, the entire set of 10 questions, that to CBSE pattern question exercise for the chapter alcohol, phenol and ether, right? So I hope everybody has revised the entire chapter, and yes, we are going to do it together, all the kind of questions that I have gathered for you, the entire lot of questions, lot of 10 questions, which are divided under 1 mark, 2 mark, 3 mark, 5 mark, right? So in such pattern, we will be discussing each and every question. Let's move on to the very first question of this lot, that is, so as it says, question number 1 to 2 is 1 mark question, fine. So we'll be having just one-liners over here. Write the IUPAC name of the following compound. IUPAC is my favorite, because if I've got it right, there is no chance that any mark will be deducted here, right? And it's very easy question here. See, what I've got, the main things, OH, that is the functional group, this is substituent, and also there is a double bond. So, we have got a preference order. Let's see the preference order first. So, it's a kind of a bit confusing question. Why? Because preference order says that functional group should be given preference over the double or the triple bond, and yes, substituent finally. Fine. So, see here, what I have got is functional group, substituent, double bond. If I try to number it from this side, right, if I try to prefer the functional group, numbering this carbon 1, what will happen is the second priority will be coming for the substituent, but it would have been the double bond to which I should give the priority, right? But if I try to have numbering from this side, what will happen? Now the double bond will be given preference and the substituent and least is the functional group. So whenever such kind of a confusing state comes up, what you have to do is always try to prefer the functional group no matter what number is given to the double or the substituent. Clear? So 1, 2, 3 and 4 could be here or here. It's one and the same thing because these are identical. I can exchange them, right? Expand your perspective, how you see the things. Fine. Now what will happen? Yeah, the name. So it is what? 2-bromo, right? So I'll be going by the alphabetical order, 2-bromo, 3-methyl, and finally 1, 2, 3, 4 bute, 2-ene, 1-ol. Yes, don't forget the alcohol. This is the very correct answer for this question. Clear? So I hope everybody has got it right. Now I'm rubbing this. Let's move on to the very next question. So this IUPAC name was kind of typical. Each and every kind of a concept was applied here. Next one, write the IUPAC name of the following. So it's again a typical one, right? It is first of all an ether, and in ether most of the times student face problem. So as I've told you, as I've given you a trick, that first is alkoxyalkane is the general name, right? Alkoxyalkane. So this alkoxy part should be O and R, right? And this alkane should be R dash. Alkane should be R dash should always be greater than R in most of the cases. Fine. So what will happen now is OR, see here, and this is R dash because this is the bigger one. Fine. So what will it be? I have to number it, that onto which position it will be, so that I can number my rest of the substituent as well. Don't forget this. 3, 4, 5, 6. So it's 1 ethoxy, yes, onto the first position I have got ethoxy. 1 ethoxy 2 nitro, right, as per the alphabetical order again. 2 nitro, and what is it? Cyclohexane. Clear? Easy? So that is the name for this compound. Clear? So let's move on further. Next one. Now the question number 3 to 5, 2 mark question. Arrange the following compounds in the increasing order of their acidic strength. Again my favorites. Why? These acidic strength, basic strength, these are my favorites, because I just have to have a very proper reason for that and my work is done. Fine. So let's move on to the very first part. Increasing order of the acidic strength I need to find out. That means paracresol, paranitrophenol and phenol, right? Let us just try to write the structures first. What is cresol? And that to paracresol. Cresol first of all means CH3 and OH. These will be added in the entire ring. Phenol I am dealing with, cresol will be CH3. Fine. Paranitrophenol, are you able to make this? Yes, it's very easy. Now add para, I need to have nitro, and finally just the phenol. First of all, why I am calling this phenol as acidic? Because these hydrogens can go off to make a very stable phenoxide ion which is resonance stabilized. That is why it readily loses this H plus. Fine. Now the presence of any kind of a group will influence the release of this H plus, right? So see here, this is showing minus I effect. In fact, not just minus I, minus R. So this is electron withdrawing group, right? This is electron releasing group showing the plus R effect, plus I effect, and what else? Also hyperconjugation, if you don't know. Yes, and this, nothing is here. Fine. So this is donating. So since this is donating, what will happen? It will increase the density itself and will not let this oxygen to release the H plus so easily. As compared to here, electron withdrawing group is there. It is withdrawing all the electrons from the ring and also from this phenoxide ion which will be formed, and thereby it can readily lose the H plus. Here nothing is present. So it is, you can say it's a kind of acidic only, right? Because again it will try to form the phenoxide ion here. So most difficult will be in this case to form the phenoxide. Second this, and very easy, super easy will be in this case where there is electron withdrawing group, and thereby I get my order, following order in the increasing order. That means starting from the very least, first, second, third. Clear? Write the mechanism using the curved arrow notation for the following reaction. So it's a very interesting one and it will be repeated again and again. In fact, this kind of a mechanism is mostly asked in the exam, right? So what do I have is, see, so they want me to complete the entire mechanism for this particular reaction which they have given. See what they have given. This is an ethene, fine. They are reacting it with the hydronium ion, right? Hydronium this is. To make what? It's a primary carbocation, fine. Ethyl carbocation in fact. So what will happen is, see, first of all, there is ethene, right? And let me just expand this hydronium. In order to get stabilized, this O has positive on O, on any electronegative atom is highly unstable state. So what should I do? This hydrogen will lose its electrons to oxygen, will go off, right? Now this is H plus there is H plus, and what will happen now? See, this H plus will try to attack on these electron clouds, fine. So this electron cloud will shift in either of the direction, see, let's say here, fine. So since negative will be developed here, this H positive will be coming here itself, right? Making it CH3, and thereby this will be developed as positive, and I get my final result, that is CH3, CH2 positive, and plus water molecule I already have lost it initially. Clear? I hope everybody is clear with the mechanism over here. So let's rub it off. We are through with question number 3 as well. So what question do I have next? Yeah, number 4. Again a similar kind of a mechanism, and yes, mark this as important. This mechanism is mostly asked in the exam, right? So what they are asking is, write the mechanism of the, so they have given 2 moles of ethanol concentrated, so it's H2SO4, correct it, H2SO4, and at 443 Kelvin, right? So basically at such a high temperature, what will happen? Ether is formed, fine. So let's see the mechanism of it. It's very simple. First will be the protonation step. Yes, so I'm just quickly doing it because we already have done this. O has got lone pairs, H positive will come up from H2SO4, will react it. It will be attracted towards the lone pairs, CH3, CH2, O positive, H, H. Fine. Now in order to get stabilized, it will take up electrons and go off as water molecule minus H2O. Right? Now what will happen? It's a positive generated. Now since I had taken up 2 moles, let's use the second mole of it. It's the time for the usage of the second mole. Right? So this will be attracted towards this lone pairs, fine. Try to remember this mechanism because we will be discussing this further also. CH2, CH3, and yes, how can I leave this hydrogen? It's still intact. Positive on the oxygen because this oxygen lone pairs has been taken by this carbon, right? Now what will happen? Simply this oxygen will try to neutralize, try to stabilize, taking this electrons to it, and this hydrogen will go off. I get my ether, right? And what is the name for this ether? Propoxypropane, yes? There is no bigger or smaller group, both of them are identical. Propoxypropane, clear? Very much? So I hope everybody has got it, and yes, since it contains 2 steps, so you will be finally getting 2 marks for it if you have written it very correct, right? Let's move on now. How is 1 propoxypropane synthesized from propane 1-all? See here. Okay. 1 propoxypropane synthesized from propane 1-all. Right? Okay, wait for a moment. What just got in my mind is in the previous question, yeah? So that is not propoxypropane. I mistakenly said that it is what? Eth is there, so it's basically ethoxyethane, right? Clear? Now, I hope everybody has made the corrections. Let's move on further. Okay, so 1 propoxypropane synthesized from propane 1-all, a similar kind of a reaction. Yes, it is. So, what should I do? Take up the alcohol which they have given, propane 1-all, and yes, always try to remember what? I need to take 2 moles. This thing, if you have mentioned in the answer, then only you will get proper marks, otherwise not, right? 2 moles will be fetching you 1 mole of an ether. And specifically what I would like to tell you over here is, although I am taking concentrated H2SO4, what is the proper reaction condition? It's 413 Kelvin basically, which is favorable for the formation of ether, right? Again a similar kind of mechanism, right? We all know that 1 mole, first will be the protonation. We have just done this. First will be the protonation, second will be attack of other molecule or other molecule, right? And thereby I will be getting 1-propoxypropane. Yes? So that is what my product will be. So you have to try this out. I am not going into the detail, it is similar kind which we have discussed earlier, right? Let us try to have the next question now. I need some variation now. Okay, here comes up the variation, and that too very good. 6 to 8 3-mark questions. Write the main products in each of the following reactions. So I need to write the main product. See here very carefully. These kind of reactions are very important. Fine? Whenever they have introduced HI. So what you are going to do is here, either you break this or you break this. Fine? Depending upon the stability. I will just tell you what stability I am talking about. Either you break this. If you break this, then what will happen? This entity O negative will be produced. So the positive part will get attached, and to the positive part the negative will get attached, right? HI this is, and that is how you need to break. But see here, usual mechanism which is followed in this reaction is SN2, right? That means the backside attack of I negative, and this is attacking backside. So it will attack towards the less bulky group, yes, towards here, and thereby favorable product should be CH3I. Fine, but not in this case. Try to mark it as important. This is an exception. Why? Here not the SN1 mechanism, SN2 mechanism will be followed, but SN1 mechanism. Because can you tell me that? SN1 mechanism is followed because here if we break this, it will form a very stable carbocation, and that is why SN1 is favored over here. And since I have got this breakage here, a positive will be developed here. This is a tertiary carbocation, and thereby I negative is definitely be going to attach towards this side, and I get is this as the product, tertiary butyl iodide plus the remaining one CH3OH. Fine? Clear? So always try to judge that is a formation of carbocation will be favorable or not, then it follows SN1, otherwise SN2. So always try to attack the I negative from the less bulky side, and yes, get that product. Clear? Now comes up the next one. What reaction is this? Again an important one, many times asked in the exam. So it's hydroboration oxidation. Yeah, hydroboration oxidation. So what will happen? Always remember, yes, I am not going into the detail for that. Hydroboration oxidation always involves anti-Markovnikov rule. Right? Always remember this anti-Markovnikov's rule, and yes, OH will get attached where? Here. Clear? So my product, my major product, main product I have to write. So it will be yes, thrice of in fact, right, as per the reaction. So you have to do it on your own, right? Next, what reaction is this? Again a named reaction. So see here, at the very first step I have got aqueous NaOH and then CO2 in the presence of H positive. What is it? It's Kolb base, right, or Kolb's, whatever you call it. Kolb's electrolysis, yes. And what will happen in this reaction is, first step, if I have got is phenol, try to react it with NaOH. Have you tried this out? So it will be ONA, right? sodium phenoxide formed. Then what will happen? Second step, CO2 in the presence of H positive. And you know what are the reaction conditions? 400 Kelvin temperature, 4 to 7 atmospheric pressure. Fine. And what do we get is, so basically in the initial step I get is OH and this sodium salicylate. Sodium salicylate, H positive comes up next. Fine. In the next step, and I get is OH and COOH. What is this? Salicylic acid, right? My main product. Clear about it? Let's try to have the next question now. So I'm just rubbing this. So this was, a very important question. We had discussed so many important name reactions here. Now the next one, state the products of the following reactions. Again a very interesting question, a kind of the question which we discussed earlier. See here, HI, this question, a similar kind is this when we try to react it with HBr. Fine. So here in the first one, is there any possibility of formation of a very stable carbocation? I am getting it or not? Not as such. Primary and primary, 0 degree and primary, there is only these possibilities, not very stable carbocations. So it will be following SN2 mechanism. Can you do that? Br negative will be trying to attack from this side, this is less bulkier, and yes, we will be getting, this will break off CH3Br along with CH3, CH2, CH2, OH. Fine? Clear? The next one. Here what will happen, see. If I try to break this, I am just checking the possibility whether I will be getting a very stable carbocation or not. First is this thing. Fine. So if I try to break this, positive comes up here. Phenyl carbocation, highly unstable thing, right? So I am not going for that. If I try to break this bond, what will happen now? A very stable ion will be formed, phenoxide ion. So that is phenoxide ion formed, yes. And now here this is not a carbocation which is formed, basically it is an anion. So the reaction mechanism will be that of not SN1. Don't think about SN1 because in SN1 we will be checking this carbocation stability basically. What we are checking over here is the carbocation, this will be formed along with the phenoxide ion, if you get it, right? So only and only SN2 will be followed over here as well. Br negative will be attacking from this side because this is less bulkier as compared to the phenyl, entire phenyl. Clear? So what I get is phenol plus C2H5Br. Clear? The very last, again a similar type, yes, which we have discussed earlier. So only this group has been changed. What will happen? It will follow SN1. Stable carbocation here, possibility is there, I negative will come up here then. Again tertiary butyl iodide plus, let me just make a C over here as well, plus C2H5OH. Clear? And yes, I get my product. Clear about it? So let's move further then. So again, these questions are being repeated very frequently and yes, also important from the exam point of view. Next, 8th, how do you convert the following? Now comes up the conversion, right? My favorite part again. Okay, phenol plus phenol to anisole. Phenol is this. I need to make it OCH3. So see here, if I get, just try to think about it in minimum steps. if I try to change this, I just need to replace this H from CH3. If I make this H a labile kind of a thing, that means very easily removable. So then I can attach my CH3 very well, right? What I am saying here, see, OH, right, phenol. Can I convert it into phenoxide? Definitely yes. Aqueous NaOH I am using. Phenoxide ion, ONA, right? Can I just have a simple substitution reaction over here? Yes. CH3Br. And now my work is done. What should I do now? NaBr will get removed. CH3 will come and attach over here. Simple. Very simple conversion to anisole. It's just that you need to know that what anisole is, right? If you don't know that, then you are not able to make it. So what is phenitol? Phenitol is C6H5 attached here. Yes, let's move further. What next reaction do I have? Conversion. Propane to ol to 2-methyl propane to ol. Very interesting one. Propane to ol, see. Propane to ol to 2-methyl propane to ol. Yes? Can I do that? I just want one CH3 over here. How can I introduce this CH3? If you try to remember the reaction for the Grignard reagents, so you know that if I've got a ketone, right? If I've got a formaldehyde, fine. So for that, what you are going to prepare? The primary alcohol, right? If you have got not formaldehyde but let's say ethanol, right? So in ethanol, you are going to prepare secondary alcohol. If you take up ketone, in that you are going to prepare tertiary alcohol, right? So I need just the ketone over here. Can I do that? Yes, alcohol on very mild oxidation. So I can use Jones reagent, I can use PCC, I can use these kind of mild reagents so that I just stop at the ketonic stage only. Fine. I get as a ketone, right? PCC is what? Pyridinium chlorochromate, right? It's a mild oxidizing agent. Now I've got the ketone, what I need is just the Grignard to convert this. So it's CH3 MgBr, yes. What should we do now? O negative, delta positive, fine. This one is delta negative, delta positive. Let's make the connections. So okay, I'm doing the connections over here itself. CH3C, OMgBr, CH3. Now one more CH3 has been attached. Just the hydrolysis and I get my product. Yes? Done? Again, I have not written all the byproducts. You have to do it something on your own at least, right? I'm not spoon feeding you. Now, the next one. Aniline to phenol, again very easy. Aniline is this. I need to have phenol produced from it. How can you do that? Just try to convert this in BDC and you get it, right? BDC always makes your work easier. So how can you make the BDC? NaNO2 plus HCl, 0 to 5 degrees Celsius, and all those conditions, you get the BDC. N2Cl, fine, N2 negative, N2 positive, Cl negative, and finally the final step. It is, you should have, this is important step, mark this as important. How can you convert BDC into OH? It's dilute H2SO4 if you take. So basically it's hydrolysis reaction only, right? And your work is done, OH will be produced, that is the phenol itself. Fine, this step only. Clear? So I hope each and every conversion is clear to you. These are typical ones and yes, a little confusing, but once you get it, once it clicks in your mind, it will be very easy, right? So for these conversions, you should have all the reactions which we have done in the chapter on your tips. In fact, not only these reactions, but somewhat related to other chapters as well. The entire organic chemistry is actually interrelated, right? So 8th question done. Let's move on to 9th. Okay, 9 to 10, 5 mark question now, right? We have to write a lot of things here. Write the products in the following reactions. Okay, very easy it seems. Yes, I have got again a similar kind of a question, right? So what is this reaction first of all? Let's move to here. It's the formation of aspirin, if you remember. See here, acetic anhydride. This is salicylic acid. What do we get here is aspirin is formed, right? Let's try to make the aspirin then. Always remember it is performed in the acidic medium. That is what aspirin is. Yes, that is the product. Clear? Again, no need to go into the detailed mechanism of it. Just the entire reaction, and yes, important one this is, right? Next one, again a similar type, but see here, there is not the formation of a tertiary carbocation, right? But also what will happen is this will only break because secondary is also stable. So we are favoring that as well. Again an SN1 followed. Fine. So what you want to do is formation of a stable carbocation. I negative will attack towards the carbocation, and these two CH2, CH3, O negative, CH3, CH2, O negative, this species, entire species will be coming towards H positive. Fine. Ethanol will be formed here. Let's try to make the entire product here. Right? It's the secondary one now, this in this case. And finally, CH3, CH2, OH. Got it? So since they are asking about write the products in the following reactions. So as much if all the products are getting formed like more than one, then write it down, right? They're not asking about only the major one, but all the products. Product or products. It could be any. Fine. The last one, CH3, CH2, okay. This is the compound having a double bond here, see, and an OH group. Fine. PCC, I just told you, pyridinium chlorochromate, it's a mild oxidizing agent. Yes, mild oxidizing agent. And see here, what is the quality feature of PCC? It does not affect the double bond, right? It will not affect the double bond, it will remain as it is. It will just mildly oxidize this OH. Fine. So what do I get is, how many carbons are there? 1, 2, 3, 4, 4 carbons. Fine. So the product will be this. This 4 carbons, right? 1, 2, 3, 4. Yes, 4 carbons, and the last carbon getting converted from alcohol to aldehyde. So in that category, in the previous case, I converted it into a ketone because it was non-terminal. But here, just pay attention, this is terminal one. So the terminal OH will be converted into a terminal aldehyde or maybe the ketone. So which one is terminal? Aldehyde is terminal. So that I've got. Clear? Let's, okay. So are we through? Yes. All the 3 parts we are through with. Let's move on further because this was the first part of the 9th question. 3 marks we have got it. Next one, give simple chemical test to distinguish between the following pairs of compounds. Now this one is important, right? The distinguish test. First is ethanol to phenol. Ethanol and phenol, I need to distinguish any kind of a test which will be given by one of them and not the other, right? So that I can distinguish that yes, in one beaker I have got ethanol and the another beaker I have got phenol, right? So phenol is C6H5OH. What could be a possible test here? So I have got 2 tests for you here, right? first is the bromine water. Can be a possibility. So bromine water test is given by phenol. How? So for this, how you have to write down in the exam, that I am going to show. Divided into two parts, fine. First is the bromine water test, Br2H2. Okay, don't just go for this heading. Just try to write down the entire reaction for it. Br2 in the presence of water, no white precipitate obtained. Why I have written white precipitate? Because in the case of phenol, it gives white PPT. So we have got a C. Phenol 3Br2 in the presence of H2. 3, why 3? Because it's a tri-substituted product that we get. So it's like this. Yes, you need to have the proper reaction for it also. Display the proper reaction, otherwise there are chances that they cut marks, right? 2,4,6 tribromo phenol, right? Clear? And yes, don't forget to write white PPT here. Why? Because the distinguished tests are such that we can able to see the difference clearly, right? Maybe there is a color change, maybe there is a smell of gas, some kind of a product which is formed, right? So that is how the tests are, right? So they can be visible, right? We can smell it also. So that is the first one, distinguished test, by which you can distinguish through the two. The next one is the iodoform test. Yes, you might be thinking of it. Iodoform can also be applied. So any one of the tests you can give, fine. So what we know about iodoform is this group or maybe these kind of groups give the iodoform, yes. So definitely it matches with our ethanol, right? So basically I2 plus NaOH gives NaOI, which is the main thing which produces iodoform. So it will give the iodoform NaOI, yes, iodoform CH3I, yellow PPT, always write, yes. If I get a yellow PPT, then it is confirmed that it is giving the iodoform, whereas here C6H5 OH plus NaOI will not give. Clear? So first is done, propanol and 2-methyl propane 2-ol. See here. First just try to write the structures for these. Propanol, two-methyl, okay, wait, sorry, 2-methyl propane 2-ol, yes. So that is a tertiary butyl alcohol in fact, fine. So one is primary, one is tertiary, yeah. None of them, first of all, let me just make it clear, none of them will give the iodoform. Iodoform is given by an alcohol something like this, see. That means a hydrogen should be there attached with the carbon, which is not there, right? So it will not give, it will also not give, fine. So what we can do is the Lucas test, remember? The Lucas test we have done, the Groves process. What is the Lucas reagent? Anhydrous ZnCl2 plus conc HCl, yes. And which one will give immediate turbidity? Here the mechanism followed is SN1, we know this. SN1 favors the carbocation formation. Which carbocation will be formed very easily? Here, the tertiary one. So it will give immediate turbidity at room temperature. Yes, whereas this one will give after heating. And yes, we have discussed this entire process in a very much detail, so I am not going into the detail for that. You have to write that down, right? Let's move on. And yes, what for your information I would like to tell you here is, one more test is there, which is given by, which is a very good test for primary, secondary and tertiary alcohols, right, basically. And that test is Victor-Mayer test. Victor-Mayer test, and yes, you can read about it. You must be having this particular test, not in NCERT included, but yes, in some of the competitive books. If you want to have more knowledge, you can read about this test, right? It's also a very easy one. Fine. So let me just go on further to the next question. Now, the 10th question, again the 5-mark question. Write the formula of the reagents used in the following reactions. Simply formula I need to write down. Bromination of phenol to 2,4,6-tribromophenol. You already have done this reaction earlier. What is this? It's the simple bromination. We obtained a white PPT. Yes. So, what is the reagent? Simple bromine water, and that too thrice of it, right? So, since this is a 5-mark question, and yes, these parts will carry 1 mark, so you have to write the entire reaction, fine. Hydroboration of propene and then oxidation to propanol, already done. Hydroboration oxidation reaction. First step was B2H6, right? Second step, hydrogen peroxide in the presence of OH negative, which has to be added to form propanol. Clear? Now, this part done. Arrange the following compounds in the increasing order of the property indicated. Very important question. Now, para-nitrophenol, ethanol, phenol. Fine. I've got 3 things here. Para-nitrophenol, a phenol, and ethanol. Yes, acidic character we have to tell. So, first of all, formation of phenoxide ion, that will be more acidic thing, right? So, out of aliphatic and aromatic, aromatics are more acidic, right? That means the least acidic will be this one first, right? Next, out of the 2, we already have discussed this. The one having electron withdrawing group will release this H plus more quickly, and this will not. So, first, second and highly acidic will be the para-nitrophenol. Clear? This one done. Now come up to propanol, propane, propanol, right? And we have to arrange these in boiling point order. Propanol, propane, propanol. Propanol, propane and propanol, right? What can you say about the boiling point first of all? Since the boiling point, I told you, whenever there has been the question related to boiling point, always try to consider the liquid state, right? And in liquid state, there will be interaction between the molecules. How the interaction has been done, see here. In case of alcohols, yes, there is H bonding, yes. Also in here, there will be H bonding, fine, but not that good as compared to the alcohols. We already have done this concept before, right? And if I try to compare it with a simple hydrocarbon, no chance of having any kind of an H bond, no electronegative atom present over here. There will be very weak van der Waals forces, right? Weak van der Waals, yes. And can I arrange this now? Least one first, next one aldehyde, and third one, the most good bonding which is existing. More the bonds in between the molecules, more they will be very difficult to break, right? And if I am not able to break them properly, very difficulty, I am facing so much of difficulty, then more of the heat will be required, right, to boil it off, to break the bonds, to make the molecules go in the vapor state, right. So, that is why the highest boiling point will be for that alcohol. So, alcohol, next aldehyde, least is the hydrocarbons, clear. So, okay, let me just check, do I have any question left? No. Yeah, that's complete. That completes the 10th question as well. I hope that is clear to you. And yeah, my entire questionnaire is also complete. I hope everybody has enjoyed that. And yes, what you have to do is revise it once again, because it has got some of the very important mechanisms that we have discussed along with such orders over here, right. So, just revise it once again. If you have any doubt, you can always ask me. I am always available for you, right. Have a nice day.